Hi there everyone, welcome back to Cody's Lab. So a lot of you, especially after my getting electricity from Moonlight video, have requested that I build a boost converter or a joule thief. These are of course about the same circuit, they just have a different switching mechanism. I will put the circuit diagram up on the screen if I remember to edit it in. This circuit takes a low voltage DC input and outputs a high voltage. And today I'm going to build one. All of the YouTubers have done it with electricity, so today I'm going to do it while doing a water change on my fish. I mean, water's close enough to electricity, right? Obviously there are a lot of differences between electricity moving through a wire and water flowing through a hose, but the similarities are enough that this type of circuit will still work. For instance, here I have a potential difference. In this case, it's a gravitational potential between the water being up here and the water wanting to flow down here. But gravitational potentials are very similar to electrical potentials. You see, electrons are going to want to fall down to a more stable state, similarly to how the water molecules are wanting to flow down into the bucket. So it's as if I have a battery here, and the electrons are wanting to flow down to, say, the other side of the battery, from negative to positive, which is very similar to electrical inductance. Another similarity between water and electricity that makes this possible is the fact that water has inertia. In fact, I'm able to create enough inertia in the water that when it stops, the water actually creates a vacuum behind it. This here is of course a cavitation bubble, and it shows you just how strongly the water resists a change in flow. It is creating a pressure differential of at least 12 psi, or atmospheric pressure. Anyone who has turned on and off an electromagnet without a shunting resistor in the coil has probably experienced a strong voltage spike, which I can recreate here. See that? How it shot the water up and over top of the water level? That's because once it reached the top, the water did not want to stop moving. Similarly, an electric field does not want to stop being around once it is started. This means that water flowing through a tube is very similar to electricity flowing through a wire that is wrapped around a piece of metal, in that it stores some energy. You see, if I try to stop the water flowing, it creates a pressure spike just as I'm turning it off. Electricity does the same thing when it has some energy stored in a magnetic field, except instead of a pressure spike, it creates a voltage spike. Voltage and pressure in this context are equivalent. Now, if I put a small hole in the end of the tube, as you can see right here, I let the water flow, and then when I shut the water off, the water is shot through that tube with a very high amount of pressure. Now, I should be able to use this to pump a small amount of water up a great height. Now, unfortunately, I can't just stick another hose on here because the water would flow into it when I turned it off. But when I turned the flow back on, the water would just flow out of this tube as well. I couldn't maintain a pressure differential. I need something that will allow the water to go one way, but not the other. In an electrical circuit, I would use a diode. But in this case, I'm going to be using a check valve. These things operate very similarly to diodes, and it even has the same symbol. So let's stick this into the hose, stick the smaller tube onto here, and let's see how high I can pump this water. So there's the tube coming off of this other tube, and right up here about 3 feet above the surface of the fish tank, I've got a little dish which will act as my capacitor. This will store the liquid once it gets pumped up here. There we go. And now I'm going to turn it on and off using my finger. Let's see if we can pump any water through this little tube. So yeah, it is working. I can see there's water being shot through the check valve. Unfortunately, not a whole lot of water. So this will be very slow, but it does look like it is working. There it goes. Water's getting pumped up. We're just about to the point where it's actually got a greater potential than the original water level in the tank. There we go. Oh, it makes less noise if I put my finger under the water. It's working. It's up above the water level of the tank. It's very slow and inefficient, but there you go. If you think about it, this plastic tube actually is acting like a capacitor as well, just with a very low capacitance. Of course, electrical wires act much the same way.
Is it dripping in yet? Oh, that's so cool. It's actually working. I'm pumping the water 3 feet straight up. One drop at a time. But the water that's up in the dish up there is going to have way more gravitational potential than the stuff that is moving down here.
So there you have it. By letting about 10 gallons of water flow down into a bucket from this fish tank here, I managed to pump about 10 milliliters of water, 9 milliliters of water, up to the top of the shelf. Obviously the electrical circuits are going to be far more efficient, but ultimately this has the same general concept. And this kind of shows you just how accurate the flowing water visualization to electricity really is. So, hope you all enjoyed. I'll see you next time.